Let us complete the slides now. So next example is verify whether the following are zeros of the polynomial indicated against them. Right? So we are going to verify the following are the zeros or not. Okay. So the last video we have seen what is the zero of the polynomial. Right? So how to find out the zero of the polynomial? When you put equal to 0, the expression given expression equal to 0, and then if you solve the given expression, you will get the value of x. That particular value of x is going to be 0 of the polynomial. But here they are asking to check whether the given number are the zeros of the polynomial or not. So the procedure is, in the last example we have seen that -1 and -5 are the zeros of the given polynomial or not. How can we how could we check? We have checked up by substituting those values inside of x, and then the value of the polynomial we found the 0, therefore they are the zeros of the polynomial. So likewise we have checked whether both are zeros of the polynomial or not. In the similar way, here also some of the questions given here. Okay, so we are going to check whether the indicated value, that is for the first question 1 by 3 is the indicated value. We are going to check whether this 1 by 3 is the zero of this polynomial or not. Okay, in the similar way, in the second one, we are going to check 4 by 5 is 0 of the polynomial or not. So likewise, right? Look at the solution now. So first one. So now we are going to check whether that 1 by 3 is the 0 of this polynomial or not. How can we check? We have to substitute this value instead of x, and after simplification, if you get 0 as the value, then that particular value is the 0 of the polynomial. Otherwise not. Okay. So now substitute here instead of x. So P of, so instead of x, replace 1 by 3 here. So instead of x, 1 by 3, so equal to 3 into, so again instead of x, 1 by 3, and then plus 1. Okay, so equal to, so here 3 into 1, 3, so 3 divided by 3 plus 1, right? Now these 3 and these 3 get cancel each other. So 1 plus 1, not 0, okay, because here we are dividing 3 by 3, so answer is 1. So 1 plus 1 equal to 2. So here we got a non-zero value which is not equal to 0. Therefore, what is the conclusion here? This 1 by 3 is not the 0 of the polynomial p of x, right? So just do it in your classwork by yourself, okay. Look at the next example. So p of x equal to 5x minus pi, and we are going to check whether 4 by 5 is a 0 of the given polynomial or not. Okay, so here pi value is given. What is pi value? So already we know that pi value is 22 by 7 or 3.14. This is also just as a constant. Okay, so no need to worry about this, right? So keep the value as it is. Now we are going to check that 4 by 5 is the 0 of this polynomial or not. Okay, so p of, so instead of x, put 4 by 5 and write the other numbers, constants, everything as it is. Okay, so 4 by 5 equal to, so 5 into, so instead of x, 4 by 5, then minus this pi value. Okay, so equal to, now simplify this. So 5 4s are 20 divided by 5, then minus pi. So here if you cancel this, means here 1 time, here 4 times. So 4 5s are 20. So equal to, the answer is 4 minus pi. So it is also a non-zero value, that is not equal to 0. Therefore, what is the conclusion here? So 4 by 3 is not the 0 of p of x, right? The next one, p of x equal to lx plus m. And we are going to check that minus m by l is the 0 of this polynomial or not. Okay, so again replace instead of x. So p of, so minus m by l, so equal to, so l into, instead of x, again minus m by l. Here I am writing through the mouse. Okay, that's why it is coming like this, and plus m. Okay, so equal to, Now multiply these two now. If you multiply means minus L M divided by L plus M. Okay. Now can we cancel L here? What about the remaining one here? So minus M plus M. So minus M plus M. So both are same value with a different sign. So they get cancel each other. So the answer is 0. Right? So when we substituted minus M by L instead of X, we got 0 as the value of the polynomial. Therefore, what is the conclusion here? Minus M by L is the 0 of this polynomial. Right? Right. And go to the next example. So fourth subdivision, P of x equal to 3x square minus 1. So now we are going to check both, that is minus 1 by root 3 and 2 by root 3 are the zeros of this polynomial or not. Right? Now we are going to check one by one. Right? By first we have to put x equal to minus 1 by root 3 and check whether it is a 0 or not. And then next put 2 by root 3 instead of x and check whether it is also 0 or not. Okay, one by one. So first I am going to put minus 1 by root 3. So P of minus 1 by root of 3 equal to 3 into, instead of x again, minus 1 by root of 3 whole square, because square is there, right? Minus 1. So equal to 3 into, if you square the numerator, okay, so minus 1 is there, so minus 1 into minus 1. Multiply 2 times, so plus 1 will come, divided by, and root 3 whole square. So root 3 whole square means we have to multiply root 3 into root 3 2 times, because the power is 2, that's why. Okay, now multiply, if you multiply we get root of 9. Now root of 9 is a square number or not? The square root of 9 is nothing but 3. So the denominator is 3 here, okay, and minus 1. So can we cancel 3 here? Definitely. What of the remaining one? So 1 minus 1. So 1 minus 1, the answer is 0. So when we replace minus 1 by root 3 instead of x, we got 0 as the value. Now what is the conclusion? So minus 1 by root 3 is the 0 of this polynomial. Okay. So next we are going to check 2 by root 3 is the 0 of the polynomial or not. Okay. Right. Now put x equal to 2 by 3, 2 by root 3. So 2 divided by root of 3. It is not z, it is 2. Okay, equal to 3 into, instead of x, so 2 divided by root 3 and square is there, so whole square, minus 1. So equal to 3 into, so now apply square on both numerator and denominator. In numerator 2 is there, so 2 square. 2 square means 2 into 2, 4. And root 3 square. Root 3 square is 3 only. Now only we found that root 3 square is 3 and minus 1. And this 3 get cancelled. So equal to 4 minus 1. So equal to 4 minus 1, 3. So this is also non-zero value. Therefore, what is the conclusion here? So 2 by root 3 is not a 0 of this polynomial. Okay. Right. Next definition, that is value of the polynomial. So what is the value of the polynomial? How can you find out the value of the polynomial? Right. So look at the definition here. If P of x is a polynomial in the form, it is a general form of a polynomial, already we know that. Okay. And if x equal to a will be given by, that is, if you want to find out the value of the polynomial P of x, okay, now we found the value of the 0 of the polynomial, right? 0 how can you find out 0 of the polynomial? Or how can you check whether it is a 0 of the polynomial or not? You have to substitute the given value instead of x, and then you have to check whether it is 0 or not. If it is 0 means it is a 0 of the polynomial, otherwise it is not a 0 of the polynomial. That is the conclusion. In the similar way, so here also we are going to replace the particular value instead of x. Okay, the value of the polynomial may be 0 or may not be 0. Alright, so these are the procedure to find the value of the polynomial. Okay, simply how can we say means, we can substitute the given value instead of x and evaluate it, we will get a value. Okay, no need to worry about whether it is 0 or not. So whatever it is, they are the values of the given polynomial. Okay. Look at the example. Find the value of the following polynomial at x equal to 3. Okay. So what is the given polynomial? So p of x equal to 2x cube minus 8x square plus 19x minus 12. That is a given polynomial. So we are going to find out the value. Okay, value of the given polynomial at x equal to 3. Right. That means we are going to substitute x equal to 3 directly here instead of x. Okay. So look at the solution now. So instead of x, I put x equal to 3. So 3 cube minus 8, and instead of x again 3 square plus 19 as it is, and instead of x 3 and minus 12 as it is. Okay. So and here 2 into, so 3 cube. So we have to multiply 3 times. Okay. So 3 into 3 into 3. So multiply. So 3 3s are 9, 9 3s are 27. So 27 will come here. Okay, inside the bracket, and minus 8 into, so 3 square. Okay, 3 square. So 3 square means 3 into 3 9, and plus, so 19 into 3. So 19 into 3, and then minus 12 as it is. Okay, now in the next stage, 2 into 27 54, and 8 into 9 72, 19 into 3 57, and this minus 12 as it is. Then after simplifying, we will get 27 here. Okay, so that is the value of the given polynomial at x equal to 3. Okay, so here no need to don't bother about whether it is 0 of the polynomial or not. They are not asking the 0 of the polynomial, and they are not asking check whether the 0 or not. They are asking to find just the value of the polynomial at x equal to 3. Okay, so the value of the polynomial now is nothing but 27 at x equal to 3. Okay, so look at the next example. So here p of x given here. Okay, so x square plus 5x plus 6, and then here the value of the p of x at x equal to 1. So instead of x, put 1. So 1 square plus 5 into 1 plus 6. Okay, and then 1 square means 1 only, plus 5 into 1 5, and then plus this 6 as it is. Now add everything here. So 5 plus 1 6, 6 plus 6 12. So the 12 is the value of the polynomial p of x at x equal to 1. Okay, so next we are going to find out the value of the polynomial by putting x equal to 0. Okay, instead of x, put 0 here. So 0 square and 5 into 0 plus 6. Okay, now 0 square is nothing but 0 only. Then plus 5 into 0 also, 5 into 0 0, plus the last term 6 here. So 0 plus 0 is 0, and the final value is 6. So what is 6 now? So it is also the value of the polynomial only at x equal to 0 here. So if you substitute different values for x, we will get different value of a polynomial. Okay, right. Today what all we have seen? So we just to recap some definitions, the basic definitions whatever we have seen in the last class, another topic polynomial, and in today's session we have seen the 0 of the polynomial and value of the polynomial. Okay, so both are almost same only. If the real number is to be 0 of the polynomial, p of a equal to 0. Okay, the definition we have seen. So what is the link between 0 of the polynomial and value of the polynomial? If the value of the polynomial at any other number is 0, then we can call that value, that particular number is 0 of the polynomial. Okay, so 0 of the polynomial is also another value, right? So 0 of the polynomial and value of the polynomial, and how can we check whether the given number or 0 of the polynomial or not, and how can we find out the 0 of the given polynomial. So this kind of some everything we have seen today. So I think everyone of you understood these concepts and the problems, everything. Otherwise, just go through once again, and still you will have any doubt, just ask me, I will clear doubt. Okay, so thank you. We will meet again.